In the previous chapter, we studied atomic structure, where negative electrons orbit a positively charged nucleus. Quantum mechanics was necessary in order to understand the properties of atoms. Now let's keep working our way inward and focus on the nucleus. Like the atom as a whole, the nucleus is also governed by the laws of quantum mechanics. The nucleus of an atom consists of neutrons and protons, collectively referred to as nucleons. The neutron, discovered in 1932 by the English physicist James Chadwick, carries no electric charge and has a mass slightly larger than that of a proton. Different elements in the periodic table have a different number of protons in their nucleus. The number of protons in a nucleus is known as the atomic number, Z. In an electrically neutral atom, the number of nuclear protons equals the number of electrons in orbit about the nucleus. The number of neutrons in the nucleus is N. The total number of protons and neutrons is referred to as the atomic mass number A, because the total nuclear mass is approximately equal to A times the mass of a single nucleon. Sometimes A is also called the nucleon number. A shorthand notation is often used to specify Z and A along with the chemical symbol of the element. For instance, the nuclei of all naturally occurring aluminum atoms have A equals 27, and the atomic number for aluminum is Z equals 13. In shorthand notation, then, the aluminum nucleus is specified as the following. The number of neutrons in an aluminum nucleus is not given explicitly by this shorthand notation. However, it can be determined easily with the A to the equation above, which indicates that N is equal to A minus Z, which equals 14 in this case. In general, for an element whose chemical symbol is X, the symbol for the nucleus is given by the following. A proton is represented by the following symbol, since the proton is just the nucleus of a hydrogen atom. A neutron is denoted this way. For the electron, we use the following, where A equals 0 because an electron is not composed of protons or neutrons, and Z for the electron is equal to minus 1, since the electron has a negative charge. While the number of protons in a nucleus determines the element, nuclei of the same element can have different numbers of neutrons. These are known as isotopes. Carbon, for example, occurs in nature in two stable forms. In most carbon atoms, 98.9% of them, the nucleus is the 612 isotope and consists of 6 protons and 6 neutrons. A small fraction, only 1.1%, however, contain nuclei that have 6 protons and 7 neutrons. The percentages given here are the natural abundances of the isotopes. The atomic masses in the periodic table are average atomic masses, taking into account the abundances of the various isotopes. The figure shows a cartoon picture of a nucleus, which consists of a roughly spherical blob of positive protons and neutral neutrons clustered together. Experiment shows that the radius r of the nucleus depends on the atomic mass number A and is given by the following relationship. This equation indicates that the radius of the aluminum nucleus, for example, with A equals 27, is r equals 3.6 times 10 to the minus 15 meters. Because the radii of nuclei scale as the cube root of the atomic mass number, the density of all nuclei is approximately the same. For example, while lead as a solid is much more dense than oxygen as a gas, the density of their nuclei are nearly equal.